Imagine standing by a still pond at dawn. The air is calm. The water mirrors the sky so perfectly that you can tell where one ends and the other begins. You pick up a small stone and drop it. Ripples spread outward, soft, delicate, inevitable. Every wave touches every part of the pond, carrying information about that one moment. Now imagine something far stranger, that reality itself is like that pond, that every particle, every atom, every breath of existence moves not by chance, but because of invisible ripples spreading through an unseen ocean beneath everything. This is Pilot Wave 2.0, a revival of one of the strangest, most beautiful, and most daring ideas ever proposed in physics. It suggests that beneath the randomness of quantum mechanics lies a hidden order, a deep current that guides every event in the universe, a hidden ocean of waves steering the motion of matter, light, and perhaps even thought itself. To understand how this idea came to be, we need to travel back nearly a century, to a time when physics was being rewritten from the ground up, the early 1920s. The atom had just been cracked open, the electron had revealed its secrets, and they were nothing like what anyone expected. Scientists had discovered that, at the smallest scales, matter behaved not like solid objects, but like rippling waves of probability. Electrons could pass through two slits at once, interfere with themselves, and appear only when measured. It was as if the universe refused to reveal its hand until someone looked. This was the birth of quantum mechanics, and with it, a revolution in how we understood reality itself. To make sense of these strange experiments, physicists like Niels Bohr and Werner Heisenberg crafted the Copenhagen interpretation, the belief that particles do not have definite properties until observed. According to this view, reality at its deepest level is fundamentally probabilistic. The universe is not a precise machine, but a great cosmic dice game. For Bohr, uncertainty wasn't a flaw, it was the essence of nature. He once said, "There is no quantum world, there is only an abstract description." In other words, the act of observation didn't just reveal reality, it created it. But not everyone agreed. Among the rebels stood a quiet, sharp-minded French physicist named Louis de Broglie. De Broglie had a thought so bold that it sounded almost heretical. What if particles are just particles? What if every bit of matter is accompanied by a hidden wave, a guiding wave, that tells it where to go? He imagined each particle as a surfer gliding on a vast, invisible sea. The wave beneath it spreads through space, determining the particle's motion. The result is not random at all. It is simply guided by a pattern we can see. De Broglie called it the double solution theory. A beautiful idea. A universe where every electron and photon follows a hidden roadmap written in waves. In his vision, the famous uncertainty of quantum mechanics wasn't uncertainty at all. It was ignorance. We couldn't predict outcomes because we couldn't see the hidden waves controlling the particles. For a brief moment, it seemed de Broglie had discovered something profound, a bridge between the classical world of Newton and the strange quantum realm. But in 1927, at the Fifth Solvay Conference, his idea was crushed. There, giants like Bohr, Heisenberg, and Born dismissed his pilot wave as unnecessary. The probabilistic interpretation, randomness itself, had already become the new gospel of physics. De Broglie's theory was forgotten. He returned to more conventional work, and the idea of a guiding wave sank into obscurity. For decades, quantum mechanics reigned supreme as the science of chance. Mysterious, successful, and philosophically unsettling. But in the shadows, the idea waited. Then, in 1952, another mind brought it back. David Bohm, a brilliant American physicist exiled for his political views, revisited de Broglie's forgotten papers. Bohm realized that the mathematics of quantum mechanics could indeed describe a world guided by hidden waves. He refined the equations, added clarity, and gave birth to a modern version of the theory, now known as de Broglie-Bohm theory, or simply pilot wave mechanics. In Bohm's universe, particles have definite positions and velocities at all times. They don't flicker in and out of existence. They move along precise paths, guided by an invisible wave described by the Schrödinger equation. That wave, however, doesn't carry energy in the usual sense. It carries information. It's as though the universe whispers to each particle, telling it where to go. This whisper connects everything. Even across vast distances, the wave binds particles together, explaining the eerie phenomenon of entanglement, what Einstein famously called spooky action at a distance. In Bohm's model, there's no need for spooky magic. The particles are connected by the same guiding wave, part of a single, vast, invisible ocean of information. What we perceive as randomness is merely the complex interaction of countless hidden ripples we can detect. And yet, Bohm's revival of the theory was met with silence and resistance. The physics community, enamored with the probabilistic view, wasn't ready to embrace determinism again. To accept Bohm's vision meant admitting that quantum mechanics, the most successful theory in science, might be incomplete. That beneath its equations, something deeper, more elegant, was waiting to be seen. Bohm didn't back down. He began exploring the philosophical meaning of his theory. If the pilot wave connects all particles through information, he reasoned, then perhaps everything in the universe, matter, energy, even consciousness, is part of one unbroken whole. He called this the implicate order, the hidden structure from which all visible reality unfolds. According to Bohm, what we see, the explicate world of forms, objects, and events, is just a projection from this deeper order, like ripples on the surface of a vast, unseen sea. The pilot wave, in this sense, wasn't just a physical concept. It was a window into the unity of existence itself. Decades later, the idea would return again, this time not in equations, but in experiments. In the early 2000s, physicists began studying droplets of oil bouncing on a vibrating bath of liquid. These droplets, nicknamed walkers, would create tiny ripples as they bounced, and astonishingly, those ripples began to guide the droplets themselves. When researchers sent the droplets through slits, they produced interference patterns, just like electrons do in the famous double-slit experiment. When trapped in circular wells, they orbited at discrete energy levels, mimicking quantum quantization. When paired, they interacted at a distance through their shared wave field. It was as if these droplets were tiny, visible quantum particles, classical systems behaving with quantum-like precision. These experiments reignited interest in the pilot wave idea. Suddenly, de Broglie's century-old vision didn't seem so impossible. Physicists began to wonder if the quantum world could really be a fluid dynamic, a hidden ocean beneath all matter, a realm of waves that never cease to move. And so, Pilot Wave 2.0 was born, not as a rejection of quantum mechanics, but as an evolution of it. It doesn't deny Schrödinger's wave equation or Heisenberg's uncertainty principle. It explains them through a deeper mechanism. In this view, the universe is not random. It's hiddenly ordered. Every particle's behavior depends on the configuration of all others, like surfers riding overlapping tides in a cosmic sea. Think about what that means. If true, it could unify not just physics, but philosophy. It would suggest that the separation between observer and observed, between mind and matter, might be an illusion, that everything is part of a continuous flow of information, eternally connected, endlessly unfolding. Perhaps consciousness itself arises from this same ocean, a ripple pattern of awareness generated by the deeper waves of existence. Maybe thought and matter are two aspects of the same underlying current. The implications stretch beyond science. If there is a hidden wave guiding every atom, then randomness, true randomness, might not exist. What we call chance could simply be complexity we cannot calculate, What we call choice might be the crest of a deeper, deterministic tide. And yet, that doesn't make life meaningless. In fact, it makes it more profound. Because in a universe of waves, we are all connected, not by chance encounters, but by shared rhythms. Every breath, every action, every thought sends ripples into the whole. So maybe the real question isn't whether the universe rolls dice or follows laws. Maybe the question is, what is the ocean made of? Is it physical, mathematical, conscious, information itself? Some physicists now believe that information, not matter, is the true fabric of reality. That space, time, and energy are all emergent, born from an underlying field of informational waves. In that sense, the pilot wave might not be just a hidden layer beneath quantum mechanics. It might be the foundation of existence itself. A few have even suggested that gravity, entanglement, and quantum fields could all be surface effects of this deeper, fluid-like substrate. If that's true, then de Broglie and Bohm were glimpsing not just an alternative interpretation of quantum mechanics, but a clue to the next revolution, one that unites the quantum and the cosmic. Imagine it, the entire universe, from the smallest quark to the largest galaxy, as patterns on an infinite ocean of information. A cosmic sea where the crests form matter, the troughs form energy, and the ripples give birth to time. In that ocean, nothing is truly separate. Every atom knows the song of the universe because it is made of that song. Every event, no matter how small, echoes through the whole. Perhaps that is why we feel connected to the world, to people, to music, to meaning, because at the deepest level, we are all waves in the same water. So the next time you see a drop of rain fall into a puddle or the wind stir ripples across a lake, remember, that motion might be the closest glimpse you'll ever get of the quantum sea beneath existence. And perhaps one day, when physics finally dives deep enough, it will find that the ocean isn't just beneath us, it is us. Because maybe the universe doesn't play dice. Maybe it plays waves, and we, everything we are, everything we know, are simply part of that eternal rhythm, the hidden ocean of reality, the silent guide beneath all things, the pilot wave. And until we learn to hear its whispers, we'll keep searching, diving ever deeper, beyond perception, beyond probability, beyond Newton,